Hi ladies, welcome to the first day of online learning for our concepts class. This is going to be a huge learning experience for all of us as we work through this. I am currently videoing this portion on Wednesday evening after struggling with trying to get some other portions up onto P-Learning for you to watch. And as we're all finding out, our systems are overloaded, the internet is overloaded, so we'll just do the best we can. So I wanted to just give you some pieces of information, but first of all, what I really want to know is, how are you ladies doing? It's definitely been a challenging time for all of us. So I have sent out I haven't sent out, but there is a link to a survey at the end of the videos for what we're going to be doing today in class. And I've posted it out on our P-Learning drive. I really just wanted you guys to check in. Tell me something about your week. Tell me something that's been going on. Tell me how you're doing. So I'm going to kind of tell you what's been going on here. So these are my two dogs. This is Coco, and this is Coco over here, and this is Carmel. And right now we are calling them the Buttheads because last Sunday, before we ended up not having school, so that was Sunday the 8th, the two of them got into a little fight, and so we've had to have them separated since then. And as a result, we are working with a trainer and having to spend a lot of time with them each and every day, working on commands and behavior modification, and it's kind of a pain. So they're still both kind of in trouble. While they're very cute, they've been very time-consuming lately. So I will say, honestly, I'm kind of glad that I've been home a little bit more. I've been able to work with them more. They're coming along nicely. They haven't had any issue since that first night, but we don't really trust them yet because there's still a little bit of territorial things going on. And it happened when they were eating their bones. You can kind of see in the picture, they each have this bone that is stuffed with peanut butter and cream cheese. And we're not sure who tried to take the other ones or who came over when the other one was eating theirs. I don't know what happened, but the next thing we know, they were all like fighting over it. So it's always interesting. And I think that night might have been a full moon. So those are my two dogs. And we started training Monday, the 16th. And we've been working with them. It's going okay, but they're time consuming. And we are affectionately calling them the Buttheads right now. So that's kind of my status. So I wanted to give you a little bit of information about how things are going to work. So probably not a whole lot different from most of your other teachers. All information for a specific day is going to be posted on P-Learning by 8 a.m., and that will be all of the B days. I am going to be using P-Learning and Edpuzzle for lessons. I am trying to avoid adding Google Classroom into the mix because I have a feeling that's just a little too much right now. Every day will comprise of a video. Sometimes it's going to be split into multiple parts. It kind of depends on how YouTube Edpuzzle is working. I'm having a little bit of difficulties with it this evening, so we'll see what I'm able to get uploaded for you guys in time for the 8 o'clock start on Thursday. So in it, normally we'll have an intro, a prayer, review questions, prime time. And I am going to continue on with having review questions submitted by students. I will personally email the students whose turn it is to do review questions and give them some guidelines for next week for Monday. And kind of at that time, I will go ahead and post that information out onto P-Learning so you guys all have it and you can kind of plan ahead. I'm going to answer questions from previous class that you submitted through the survey, which you're going to see at the very end, as well as going over homework or items turned in if I have comments. Then I'll dive into explaining new topics, doing example problems in your packet, and concluding with identifying what needs to be turned in as classwork, which we're defining as things you normally would have done in the classroom or while you're doing the video. And those are going to be due the next day by 8 a.m., so you have 24 hours to work on it, as well as identifying what would normally be turned in as homework, which would be due the next B day at 8 a.m. Things are really not going to change a whole lot for what we're doing. Your homework's still going to be consisting of what you're reading out of the textbook and reading notes and self-checks. Classwork, there's going to be worksheets and doodle note sheets in the packet. So all of that information is up and available for you and will be on P-Learning. So if you are missing things, I believe I have all the documents up on P-Learning that we are currently working with, both in the blue packet, and we're going back and completing some bottoms of pages in the pink packet that we didn't complete previously. So you should have everything, and you should have access to everything if you don't happen to have it at home with you. So as far as grading the assignments, all items that are due are going to be contained within the video, PowerPoint, and posted on P-Learning as an assignment with a due date. Grading is still going to be for completion instead of correctness. So late work is going to be turned in before the next B day at 8 a.m. Will be 20% reduction of points. Late work turned in after the next B day at 8 a.m. will be 50% reduction of points because the answer key will be posted by that time, and late work after a week will receive a 0. So this is to try to keep us on top of it, not put everything off to the last minute, and keep us moving forward. So the other thing that I wanted to go over with you is something that I'm putting out on P-Learning is kind of the agenda with all the information, and each day we have a B-Day concepts class. I will put this up there. So for example, you'll see for today, Thursday, March 19th, 2020, the homework that was due today was 3.1 and 3.2. The things that you're going to need for today include the blue packet and the pink packet. The outline for today is a video on Edpuzzle containing this welcome, some information on states of matter, difference between physical and chemical properties, starting the difference between physical and chemical changes, as well as what else you're going to look for things. End of class survey is a form for you to really do kind of when you're done with at least the classwork portion, because I really want to get some feedback on, is the video working? Are you able to at least slow it down enough if I'm talking too fast? Are you having any issues? And also, if you have any questions over the content, that's the best time to ask me, and then I can take a look at all of those and make comments the next time I'm videoing, answer questions directly to students if I need to. So resources are going to include the videos on Edpuzzle, blue packet file, pink packet pages, Chapter 3, Day 1 PowerPoint. And here I've identified the classwork that's due 8 a.m. on Friday. It's going to be these pages. Homework due 8 a.m. on Monday is going to be this information for your from your textbook. And then I will always have a look forward to next week and kind of what we're doing. And I'll talk about that more in detail in the video that I've already made that you should be watching next. So that is kind of what we're doing in a nutshell. That gives you an idea of how I'm going to work things. I'm going to try to keep them as similar to class as possible in hopes that this is some sort of normalcy. So I believe that was everything that I really wanted to go over before I go ahead and merge this in with the other video. So Ladies, good luck today, and I hope that you're able to progress through everything well. And I think an Our Father would be a really good idea to kind of get us going and get us started. So, Our Father, who art in heaven, hallowed be thy name. Thy kingdom come, thy will be done, on earth as it is in heaven. Give us this day our daily bread, and forgive us our trespasses, as we forgive those who trespass against us. Lead us not into temptation, but deliver us from evil. Amen. So, ladies, this is the end of the intro part of the video. There's two other sections. One is the prime time, and one is the content. So I'm going to work on trying to merge those, so you may actually watch this as an all one entire video instead of 3 separate videos. Hi ladies, so today for prime time we're going to start by filling out the doodle note sheet in your blue packet. It's on page 5. So I have the key up on the board, and if you take a look here you can see that there are some key things that we've actually already talked about. We've given the definition of matter as being anything that has mass and takes up space, as well as the states of matter. We have not been talking about plasma, nor are we going to in this class. You may be talking about plasma next year. So for us, we're just considering solid, liquid, and gas. Under the solid box, we have the state of matter with a definite shape and volume. Molecules are arranged in a regular repeating pattern, closely packed, but can vibrate in place. And the picture is similar to the one that you drew back when we were covering the middle school chemistry packet. We've got liquid, the state of matter with a definite volume but no definite shape. Molecules are loosely packed and can flow against each other. And another drawing very similar to what we saw in the middle school packet. We have gas, the shape of matter, or the state of matter with no definite shape or volume. Molecules are very far apart and can move freely. Picture again very similar. I have already filled in for you this kinetic energy circle down here that says energy of motion. From highest molecular kinetic energy to lowest, gas is the highest. It has the highest motion, then liquid, and then solid, which has the lowest. You can also see that there are the names of the phase changes as we go between solids and liquids, liquids and solids. So some of these you're already familiar with, probably freezing and melting, condensation, evaporation. The two that most students are not familiar with at this time are the phase change when something goes directly between a solid and a gas, and that's called sublimation. And the other is gas to a solid, and that's called deposition. So the solid to gas, if you think about it starting with a solid, the word starts with an S. That's how I help remember that sublimation is the one that goes from solid to gas, and deposition is the one that goes the reverse direction. So I'll give you a few minutes to work on this. When you're done, go ahead and start the next video. So ladies, let's get started with chapter 3. There's a number of topics that are in this section, and we are going to cover today the first 2, states of matter, solid, liquid, and gas, which you already did in the prime time. And I'm also going to cover physical properties versus chemical properties. We are going to introduce physical changes versus chemical changes, but that is as far as I expect to get today. We'll pick up there next week on Monday when I get back with you, and we'll continue on through the rest of the chapter. There's not a lot of challenging content in this chapter. It's mainly learning the definitions and ensuring that you can identify what's a physical property and what's a chemical property. So let's get started. So all elements have certain characteristics that help us tell them apart from other elements. And we've already talked about observations being qualitative and quantitative. Now we're going to talk about properties, and there are two types of properties. There are physical properties that don't require you to change the element in any way to test or see that property. And a good example is the color of an element. Some characteristics are chemical, and they do require you to actually change the element in order to test or see them. For example, what the element will react with. So let's go through some examples so you can get the idea. Melting point of a substance is a physical property because it's the temperature at which it turns from a solid to a liquid. Every substance has its own unique melting point. Boiling point is another physical property. All liquids have their own unique boiling point, and that's the temperature at which the liquid starts to boil and turns into a vapor or a gas. There's another physical property which you may not have heard of before, which is called luster. Luster is the amount of light a substance reflects. It could be shiny, like a brand new copper penny, or it could be dull, and that would be a very old penny. And it may actually have even some other things on it, but right now we're just talking about how shiny it is or how dull it is. Ductility is probably a term that you're not familiar with. How ductile a substance is means how easy it is to draw it out into a long, thin wire. Some things break before you're able to make a very thin wire. Other things can be stretched easily. So it really depends on what the material is. And I remember this term because our ducts in our home are made out of these thin coils, and they're all kind of wrapped together as the picture on this one side shows. Malleability is how easy it is to be made into thin sheets. So that means that it can be hammered, it could be stretched, it can be shaped, it's very flexible. Items that are brittle are very stiff and rigid, and if you try to bend it too much, it actually cracks or breaks. So malleable and brittle are exact opposites. Density, a term that you already are familiar with. The density of a substance is how much mass it has compared to how much space it takes up. Remember that we talked about heavy is referring to an object's weight, but when we talk about density, you don't say that something has a heavy density. You say something has a higher density or a lower density. Hardness is another physical property. It indicates how well the object resists being changed when you add a force to it, like scratching a diamond. Diamond is the hardest substance that we know at this time. Conductivity, whether something allows electricity to flow through it, or if it's an insulator and it resists the flow of electricity. Now on to some chemical properties. Burning is definitely a chemical property. How fast it burns, how easy it is to burn, whether it gives off light when it burns. Anything that gives you an indication of how the substance would react when you burn it or apply a flame or heat to it will give you an indication of its chemical properties. Toxicity, the degree to which a substance can harm a living organism. So how toxic a substance is can help you to identify what it is. Reactivity. Reactivity of a substance measures how it reacts with other substances. If it reacts often with many different things, it's highly reactive. If it rarely reacts, it has a low reactivity. Some of the examples that we have here are the copper reacts with the oxygen in the air to form the blue-green that we have and can see on the Statue of Liberty. Iron also reacts with oxygen to form rust, which we've seen on a lot of different pieces of metal, especially here during the winter time. Things that fizz or change color are also indicators of things that have a chemical reaction. In addition, the half-life of a substance gives you some information about radioactive materials. It tells you how long it takes for half of the material to decay to another material. And the longer that half-life is, gives you an indication of how radioactive that material is. So with all these terms that I just kind of went over, these are not things that I expect you to know or have memorized. What I do expect is for you to become familiar with them and be able to identify what's a physical property of matter versus what is a chemical property of matter. So we are going to turn to your blue packet, page 6, and I want to work through some of these with you. So number 1, how a substance appears due to the wavelength of the light reflected off of its surface. We're first supposed to identify what the property might be and whether it is a chemical or a physical property. So for this first property, this one is color, and it is a physical property. Number 2, the ability of a substance to flow easily. If we go down and look at our word bank, the item that appears to be the best fit here is fluidity, and that is a physical property. It is not reacting with anything else. Number 3, a material's ability to be stretched into a wire. We just talked about that. That's ductility, and that is also a physical property. Number 4, the amount of heat a substance absorbs to raise the sample 1 degree Kelvin. And it should also say per unit mass here. That is actually called specific heat. This is a physical property. This has nothing to do with it reacting or turning into another substance. You're actually just applying some heat to it. Number 5, the ability of a substance to burn or ignite. This is flammability, and this is a chemical property. Number 6, the amount of matter in a sample is known as its mass, and that is a physical property. Number 7, the temperature at which a substance melts to form a liquid from a solid is known as its melting point. That is a physical property. Number 8, a measurement that determines how hot or cold a sample is, that's temperature, and that is a physical property. Number 9, the amount of light or radiant energy given off of a sample per unit area of that sample's surface. That is a physical property. Number 10, when a substance reacts chemically to create a new substance, will that new substance have the same physical and chemical properties as the initial substance? Explain your answer. So in this case, the new substance will most likely have very different properties, both physical and chemical from the initial substance, because it's a brand new material and it will probably have totally different properties. We will come back to number 11 in just a minute. So, physical properties of matter can be separated into two other groups. There's extensive properties, and those types of physical properties are dependent on the amount of substance present. So the mass, the length, the volume. Intensive properties are independent of the amount of substance present. One example is density. Chemical properties are not separated into two groups. So we are going to want to go back and take a look at some intensive and extensive properties. So let's go back to our pink packet, page 20, 21, and 22. These are the parts on the bottom that we did not do previously. So measuring length, which was page 20. Number 10, SI unit for length. If you don't remember, it happens to be meter. Number 11, 5 other units used for measuring length. You should have a number of things that you can put down there. I'll give you a moment. Number 12, if you add more mass to a sample of a particular substance, will the length of that sample change? Usually, yes, it will. So therefore, it is an extensive property. And I'm going to give you a moment to do number 14. Going on to the next page in your pink packet that we didn't do previously, which was the bottom of page 21. Number 11, what is the base SI unit for temperature? It's Kelvin. 12, list 2 other units used for measuring temperature, Fahrenheit and Celsius. 13, if you add more mass to a sample of a particular substance and the more mass you're adding is at the same temperature as the initial sample, will the temperature of that sample change? No, it will not. So therefore, temperature is an intensive property of matter. Page 22. What is the base SI unit for volume? Cubic meters. Number 10, list 2 other units that you would use for measuring volume. You can do that. Number 11, if you add more mass to a sample of a particular substance, will the volume of that sample change? Yes. So therefore, is volume an extensive or intensive property of matter? It would be extensive. So let's go back to the page 6 in the blue packet that we've already identified the physical properties for each of these and determine which ones of these are intensive and which ones are extensive. And I'd like you to write either I or E next to where you circled the physical property. So for the first one, is the color affected by adding more to it? No, it's not. So in this case, I'm going to try to write here. No. So in this case, you would put an I next to this one. Number 2, the fluidity, the ability of the substance to flow easily. If you add more, is that going to affect that property? No, it won't. That will still be an intensive property. Ductility is a physical property. If you add more to that, it will not affect it. So this all 1, 2, and 3 are all intensive. Number 4, the amount of heat a substance absorbs to raise the sample 1 degree Kelvin per unit mass. That is also intensive. Number 5 is a chemical property, so it is not separated into intensive and extensive. Number 6, the amount of matter in a sample is mass, and yes, the mass will change when you add more to it, so that is an extensive property. Number 7, melting point. The melting point is not going to change if you add more to it, so this one is intensive. Number 8, the temperature is not going to change. We already said that on the other worksheet. And irradiance, that's also not going to change. So that is also an intensive property. So if you go down to the bottom of this page, you will see number 11 says, which of the following properties are intensive physical properties? List them below. So you can go ahead and list all of the ones that we identified. And then the only extensive one we identified was mass. So for classwork practice, I would like you to do page 7 in your blue packet. You're going to identify whether it is a physical or a chemical property, as well as identify if it is an intensive or an extensive property. So your page for that looks like this. And once you've identified the physical property or chemical property, every place there is a 1, you're going to end up putting that letter down here in all these spots for the number 1. And you should end up with a sentence at the end that actually makes sense. And it's a pun, so it's one of those corny puns like we used to see back in MOP apps and some of the physics classroom things. So page 7 is for you to do on your own for classwork. So switching gears, we are going to be talking about physical and chemical changes. And you are going to be on a page that looks just like this in your packet. And this is page 8. You're going to go ahead and take a few notes here. And then we are going to wrap up for the day. So physical and chemical changes are going to be very similar to physical and chemical properties, and that's why we teach them together. So we experience physical and chemical changes every day when we cook an egg, burn gasoline in the car, freeze water to make ice cubes, mix vinegar and oil to make salad dressing, and hundreds of other things. In a physical change, the substance involved remains the same. Most physical changes are very easy to reverse. So, for example, physical change includes things like changes of state, where you go from a solid to a liquid to a gas, and the reverse. Another example is dissolving solids into liquids. So salt dissolves into water, Kool-Aid dissolves into water. We don't actually change the materials, they're not reacting. You could still separate out the salt from the water. The water has now become salty when you drink it. Another category, which is not on your page that you should be filling out, is adding to or removing parts of an object. So things like tearing or ripping, folding, taping. You're not actually changing the substance. You might be changing the size, you might be changing the shape, but you're not changing it into a totally different substance. Chemical changes are a little bit different. That in a chemical change, the original substance is changed into one or more new substances. The new substances have different properties from the original substance, and most chemical changes are very hard to reverse. So down at the bottom, you have in your thing, it says clues that a chemical change has occurred. I've ended up rewriting in there that there are 5 clues that a chemical change has occurred. The first is a new color appears. So this is an example of a color change. So you can see he's adding purple stuff to a clear solution.
You can see it's decolorizing straight away.
But you would think that it should stay purple, or at least light purple.
So what's happened now, I didn't wash the thing out properly, and we had some peroxide left. And now it's reacting faster than we can add the permanganate. That's pretty cool.
So that is one example of a chemical change, and you know it's happened because it has a color change. Another is when you have heat or light given off. So here's another one.
Wow. And look at all the sulfur on the sides of the tube. I can smell it.
So you can tell that there is a chemical reaction going on here because heat or light is given off. Another example is when we have gas bubbles that form.
What's up, everybody? Welcome back to my laboratory where safety is number one priority. And today, I'm gonna drop blood into hydrogen peroxide. Let's check this out. Kids, do not try this at home. I'm gonna grab 3% hydrogen peroxide, put it in a container just like that. And then I have pork blood and beef blood.
So he has blood and hydrogen peroxide.
And let's see what happens. I got blood in this too. Let's do it.
So you can see that there's bubbles being formed, which is no different than when you have a cut and you put peroxide on it and it bubbles.
First, I'm gonna put hydrogen peroxide.
There's a chemical reaction occurring.
Now I'm gonna grab some blood and pour it in the hydrogen peroxide and let's see what happens. Pretty incredible. So, tell me in comments.
So that is the third clue that tells you that a chemical change has occurred. The fourth one is that a solid material forms in a liquid. We call this a precipitate, and it's precipitation. So this one's actually pretty neat. He's dropping some liquid in here, but watch what happens when it falls into the tube of liquid. You've got this nice solid that appears and drops to the bottom. So not only do we have a color change happening here, but we also have a solid material that is forming in the liquid. So that's kind of neat. So those are 4 of the ways that you can visually tell that a chemical change has occurred. The 5th way is an unexpected temperature change occurs, and there's really no way for me to show you a video in which that is obvious to you, but I can describe to you the instant hot packs or instant cold packs that you probably are all familiar with. They start out at room temperature, and you typically have something in them like a metal disc or 2 separate sections that both have liquid in them, and you squeeze them and pop the disc or squeeze them such that the 2 liquids mix, and you immediately get something that's very hot or very cold. So that tells you that some type of chemical change has occurred. So again, to repeat, these 5 clues that a chemical change has occurred are all going to be things that you're going to want to memorize. You're going to want to memorize these 5 clues because they're going to be helpful to you when you're doing labs, when you're identifying whether something is a chemical change or not. How do you know that a chemical reaction occurred? You will know if you see any of these 5 things. So the first one again is that a new color appears. And the color needed to be unexpected. If I mix blue with red and I get purple, that's really an expected color change. So that's not the type of color change that we're looking at or talking about. Second clue, heat or light is produced or absorbed. Most of the time we're going to see heat or light being produced as opposed to absorbing. Third clue, gas bubbles are formed. Fourth, a solid material forms. And 5th, there's an unexpected temperature change. So this is where I'm going to conclude the information part for today. So I'd like to let you know what you're needing to submit on PowerSchool for your classwork grade. You're going to submit your blue packet pages 5, 6, 7, and 8. And since you should be handwriting these into your packet, you're going to want to take a picture of them and upload them to PowerSchool. In addition, since we finished up pink packet pages 20, 21, and 22, I'm going to ask you to go ahead and upload those also. And you will find those under the assignment information for concepts. Finally, I am going to request that you complete this survey. I'm going to put the link up on P-Learning so that you can click on it. That is really just a check-in on how you're doing, how things are going, how did this lesson go, did it make sense, do you have any questions? Since right now I can't interact with you, I am hoping that most of it did make sense and that you didn't have any issues following the material, knowing that if I talk too fast, you could always pause it and replay it. But I just wanted to kind of check in with you guys at the end and see how it all went. So ladies, please take the survey seriously so I have some feedback. I will be working to post stuff for next week as soon as I get things done over the weekend. This first time, as I said earlier, is definitely a trial one. I am learning as I go, as well as all of your teachers are doing the same. So, ladies, hang in there. Finally, I wanted to talk about what your normal homework would be, and I'm still assigning that. So this is actually due Monday, the 23rd at 8 a.m. So we're going to continue on with sections 3.3 and 3.4, so reading, notes, self-check, and questions 19 through 29. Section 3.3 is really, really short, and I was thinking about just assigning that, but when I looked at the calendar, I thought, I think 3.4 is a little bit longer. I would rather have you do that over the weekend rather than assigning it Monday to Wednesday. So I'm still assigning 3.3 and 3.4 with those questions 19 through 29 due Monday. And on Monday, there will be another video for you, and it will be up and ready to go as soon as I'm able to get it all ready. Finally, a look ahead to next week. We're going to continue working through the rest of Chapter 3 during the week. It normally takes 3 class days for me to cover Chapter 3. It's a very short chapter. Chapter 4 is quite long, so I'm really not going to spend a ton of time on Chapter 3. In addition, next week, I'm going to review your test from last week, discuss some answers and how to improve your grade. I had made some comments in PowerSchool, but I will go over those a little bit more thoroughly next week. In addition, if we had been in class, we would be doing a lab. Instead, I'm going to ask you to print out a lab handout and data sheet. I will do the lab and video it, and I'll guide you through filling out the data sheet as you watch the video. And then I'll discuss how to type up your lab report, submit that via PowerSchool, and we'll continue on in that manner for a couple of labs. Honestly, this chapter has a number of labs that we would do if we were together. I am hoping that when we get back together that we will have the opportunity to do those. There's some really fun things and there's some neat things to do. There's actually one that I think you're going to be able to do at home with things that you have commonly done around the house, but I'm still working on that to try to ensure that we can do that reasonably. So I will be back in touch with you about that. And like I had indicated in some of the other information that's uploaded to P-Learning, I'm really not sure about assessments for this chapter. I'm not exactly sure of the best way of doing this. And there's a couple of things in this chapter that are going to be really important for you to know down the road, because these 5 ways that you can tell if there's a chemical reaction, you're going to need throughout all of next year. So it's going to be important that you memorize those. So ladies, I'm going to wrap up for now, And I hope that you found this to be similar to what we would do in class. And if you have any questions, please submit them in the survey that the link will be posted for you to access. And take care of yourselves this weekend. Get some rest. Try not to stress out. Know that we're all in this boat together and we're all going to hang in there and get through all of this. So ladies, take care. Have a good weekend. And I will be back with you on Monday.